Hey folks, this is section 3.7. We are talking about finding zeros. I'd like for you to go all the way to the end of your notes. This is the section that says finding rational zeros. So we're not just finding possible zeros here, we're actually finding the rational zeros, the actual zeros of our polynomial. I have a how-to list here. You probably want to learn this how-to list, know it so that you can be able to do what it takes to find your zeros. Number one on the list, determine the max number of zeros by degree. You've done this before. This is old, so you remember you look at your degree, that'll tell you how many zeros you have. Number two, make a good list of guesses. This is something that we would have just discussed in class. This is where back in the last on the last page here, we would look at the factors of the constant and divide by the factors of the leading coefficient. Number three, you get to graph it on the calculator. We want to narrow down to one of our good guesses, so you're just simply looking at the picture of the graph and making a good guess. Number four, you're going to use synthetic substitution to be able to plug in the one that looks the best. We know that if it really is a zero, you're going to get a remainder of zero. If it's not, go back to your calculator, see if there's one that looks like a better guess. And then number five, if your depressed polynomial is a quadratic, we know that we have four methods of solving quadratics. If it's not, you got to go back to the calculator, pick another one, and plug in until your quadratic occurs. You have to keep going until you get to that quadratic. So what I'd like to do is I would like to take this list and I would like to work on the harder question here, number 64. And the reason that this one's harder, obviously, is because of the fractions. And I know y'all don't like working with fractions, so I'm going to choose to work this one for you. First thing is, let's see if we can't get rid of that fractions. You know that you've done this before by finding the common denominator and then multiplying on both sides by the common denominator. You can see that the common denominator is 7, so we're going to multiply on both sides by that common denominator. On the right side, we'll distribute. So on the left, we just have 7 times p of x. And on the right side, you've got 10x to the fourth. You guys know how to distribute. Minus 7x cubed minus 49x squared plus 35x minus 5. And you say, why is this even legal? The nice thing is that both of these polynomials have the same zeros. One of them, you understand that the minute I multiply by 7, that's a vertical stretch of 7. And that does make the graph go taller, stretching it vertically. However, this does not change the zeros, and that's ultimately what we're trying to do right now. I'll show you a picture of both of them here in just a moment. So number one in our list says that we should figure out how many zeros we're going to be looking for. Since the degree is, yep, you guessed it, 4, we are looking for 4 zeros. Number two on our list says let's make a list of good guesses. So it's definitely easier to work with the one that doesn't have the fractions in it. So let's work with that second one. Our constant is 5, which has factors of 1 and 5. Our leading coefficient is 10. Factors here, 1, 2, 5, and 10. We're going to take the factors of the constant, 1 and 5, and divide the factors of the leading coefficient. So our good guesses, we'll put over here. We want our 1 and our 5 to divide the 1, the 2, the 5, and the 10. Of course, we'll split these up properly. So our list of good guesses would look like the following. Plus or minus 1, plus or minus 5, plus or minus 1/2, plus or minus 5/2, plus or minus 1/5, plus or minus 5/5, but I don't need to write that one, I already have that one. And lastly, plus or minus 1/10, and plus or minus 5/10 is the same as 1/2, so I don't need to write that one either. So I have a total here of 12 good guesses. Our how-to list says that I should head to the graphing calculator next to narrow down which one would be the best. It sure would be nice if we had one that was one of these whole numbers, but we'll find that out by graphing. So let's take a look at what your graph should look like. And what you have here, the blue graph is the one that has the fractions. The red graph is the one that has all whole numbers. And you notice that all the zeros, and there are 4 of them, 4 times that it crosses over the x-axis, all the zeros are exactly the same, even though one is stretched vertically. The red one is stretched vertically. Unfortunately, neither 1 nor 5 is a nice 0. So we're going to have to go with something a little bit uglier. And you'll remember we were using a 1/2, a 1/5, and a 1/10. All of those are between 0 and 1. And you can see that there are 2 zeros between 0 and 1. So let's try one of those. We'll try the 1/2. And we want to use the one that has the whole numbers in it. That's a much easier equation to work with. So let's use some synthetic substitution. We're going to try plugging in a 1/2. Got 10, -7, -49, +35, and -5. All right, so bring down your leading coefficient of 10. Half of 10 is 5. Add, you have a -2. Half of 2 with a negative is -1. Add, you've got -50. Half of 50 with a negative is -25. Add, you have 10. Half of 10 is 5. And we have a remainder of 0, which is exactly what we wanted. Now let's go back up to our how-to list, because our how-to list said that we should plug in the best one and we should get a remainder of 0. We did. But number 5 says that if our depressed polynomial is quadratic, unfortunately it is not. So we're going to have to go back to our graph and see if there's another good guess that we can use. Well, remember that there were 2 zeros between 0 and 1. So let's try the other one. It has to either be 1/5 or 1/10 according to our good guess list. So we're going to try 1/5. I'll change colors so that you can see the difference. If we try 1/5 here, remember that you always want to plug into the depressed polynomial. Do not go back to the original. So bring down that new leading coefficient, which is 10. You could ask yourself, what is 1/5 of 10? I'm going to say, what's 10 divided 5, which is 2. Add, you get 0. That one's easy. 0 times a fifth is 0. Just going to give you -50. A fifth of 50, or 50 divided 5, is 10 with a negative. And that was also a good guess. And thankfully now we have our quadratic equation. So we have 10x squared minus 50 equals 0. You can use the onion layer method on this one. So add 50 to both sides, divide 10, and then take the square root. Don't forget your plus or minus. So now what I have here is I actually have all 4 of my zeros, and that is going to be part of the directions here. If you'll notice, letter C says to find all the rational zeros. So let's make a list of our zeros. So we have our first 0 that we tried was x equals 1/2. The second one was x equals 1/5. And then the last 2 that we got, x equals a positive square root of 5, and x equals a negative square root of 5. Now, notice, and I didn't read these directions out loud to you, but notice that part D says that we should also factor our polynomial. So let's take our list of 4 zeros, and let's turn those into factors. You've been doing this all semester long, so this isn't anything that's new. So first factor, x minus 1/2. Second factor, x minus 1/5. Third factor, x minus the square root of 5. And the last factor, x plus the square root of 5. So the only other thing that we have to do to complete part D is to write our polynomial, not just as a list of factors, but as a product of factors. I'm going to leave a little space before I start my first factor. We have x minus 1/2, x minus 1/5, x minus the square root of 5, and x plus the square root of 5. The only other thing that I'm concerned about is you'll notice that my leading coefficient of this polynomial is just a 1. And my original leading coefficient on the original question was 10/7. Those two leading coefficients have to match. So I need to take my 10/7 and I need to put that in the front. And now my two leading coefficients match. And I have done exactly what I was supposed to do. Part A said to list the possible zeros. Part B said to graph. Part C said to find my zeros. And Part D said to factor.